Calculate the molecular mass of sucrose, C12H22O11. Solution. The molecular mass of sucrose, C12H22O11 is 12 into atomic mass of C plus 22 into atomic mass of H plus 11 into atomic mass of O equals 12 into 12.011 U plus 22 into 1.008 U plus 11 into 16.00 U equals 144.132 plus 22.176 plus 176 equals 342.308 U. Example 1.2. The mass percentage of elements in a compound is H equals 9.15%, C equals 54.53%, O equals 36.32%. The molecular mass of the compound is 132.16 U. Find the empirical formula and the molecular formula for the compound. Solution. Step 1. Conversion of mass percent to grams. From the mass percentage of elements, we can say that 100 grams of the compound contains 9.5 grams of hydrogen, 54.53 grams of carbon, and 36.32 grams of oxygen. Step 2. Convert into number of moles of each element. We divide the above obtained masses by their respective atomic masses to get the number of moles of each element. Number of moles of hydrogen equals 9.5 by 1.008 equals 9.42. Number of moles of carbon equals 54.53 by 12.01 equals 4.54. Number of moles of oxygen equals 36.32 by 16 equals 2.27. Step 3. Divide the mole value obtained above by the smallest number. In our case, the lowest mole value is 2.27. We divide all the three mole values to get a ratio. For O, 2.27 by 2.27 equals 1. For H, 9.15 by 2.27 equals 4. For C, 4.54 by 2.27 equals 2. Thus, the ratio of the elements is 1:4:2 for O is to H is to C. In other words, for C is to H is to O, the ratio will be 2:4:1. Step 4. Write empirical formula by mentioning the numbers after writing the symbols of respective elements. From the ratio, we have the empirical formula to be C2H4O. Step 5. Writing the molecular formula. The empirical formula mass for C2H4O is 2 into 12.01 plus 4 into 1.008 plus 1 into 16 equals 24.02 plus 4.032 plus 16 equals 44.052 grams. We divide molar mass by empirical formula mass to get N equals 132.16 by 44.052 equals 3. We now multiply the empirical formula by N to get the molecular formula as C2 into 3 H4 into 3 O1 into 3 equals C6 H12 O3. Example 1.3. Find the amount of water produced by combustion of 32 grams of methane gas. Solution. Molecular weight of CH4 equals 1 into 12 plus 4 into 1 equals 12 plus 4 equals 16 grams. We write a balanced chemical equation of the reaction. CH4 gas plus 2O2 gas gives CO2 gas plus 2H2O gas. From the equation we can say that 1 mole of CH4 gas gives 2 moles of H2O gas. The molecular weight of 2 moles of H2O equals 2 into atomic mass of H plus 1 into atomic mass of O equals 2 into 1 plus 1 into 16 equals 2 into 18 equals 36 grams. Thus, 2 moles of H2O gas would weigh 36 grams. We can now say that 16 grams of CH4 gas produces 36 grams of H2O gas. Therefore, 32 grams of CH4 gas would produce 36 into 32 by 16 equals 72 grams. Hence, combustion of 32 grams of methane produces 72 grams of water, gas. Example 1.4. Calculate the number of moles of methane gas required to produce 88 grams of CO2 gas on combustion. Solution. Molecular mass of CH4 equals 1 into 12 plus 4 into 1 equals 12 plus 4 equals 16 grams. Molecular mass of CO2 equals 1 into 12 plus 2 into 16 equals 12 plus 32 equals 44 grams. We write a balanced chemical equation for the reaction. CH4 gas plus 2O2 gas gives CO2 gas plus 2H2O gas. From the equation we can say that 1 mole of CO2 gas is obtained by burning 1 mole of CH4 gas. Thus, 44 grams of CO2 gas is obtained by burning 16 grams of CH4 gas. Thus, 88 grams of CO2 gas would be obtained by burning equals 88 into 16 by 44 equals 32 grams of CH4 gas. 16 grams of CH4 gas constitutes 1 mole of CH4 gas. Thus, 32 grams of CH4 gas would constitute 32 into 1 by 16 equals 2 moles of CH4 gas. Therefore, 2 moles of CH4 is required to produce 88 grams of CO2. Example 1.5. 60 kilograms of N2 gas and 10 kilograms of H2 gas combine to produce NH3 gas. Find the amount of NH3 gas formed. Also, identify the limiting agent in this process. Solution. Molecular weight of NH3 gas equals 1 into atomic mass of N plus 3 into atomic mass of H equals 1 into 14 plus 3 into 1 equals 17 grams. Let us write the balanced chemical equation for this reaction. N2 gas plus 3 H2 gas gives 2 NH3 gas. Moles of N2 equals 60 kilograms N2 into 1000 grams N2 by 1 kilogram N2 into 1 mole. N2 by 28 grams N2 equals 21.43 into 10 raised to 2 moles. Moles of H2 equals 10 kilogram H2 into 1000 grams H2 by 1 kilogram H2 into 1 mole H2 by 2.016 grams H2 equals 4.96 into 10 raised to 3 mole. As per the above chemical equation, we can see that 1 mole of N2 requires 3 moles of H2 for the reaction. Hence, 21.43 into 10 raised to 2 moles of N2 would require 21.43 into 10 raised to 2 moles N2 into 3 moles H2 by 1 mole N2 equals 64.29 into 10 raised to 3 moles H2. But we have only 4.96 into 10 raised to 3 moles H2. Hence, dihydrogen becomes the limiting reagent in this case. Hence, the amount of NH3 formed shall depend on the amount of dihydrogen present, meaning it would be formed only from 4.96 into 10 raised to 3 moles. Since 3 moles H2 gives 2 moles NH3, 4.96 into 10 raised to 3 moles H2 gives 4.96 into 10 raised to 3 into 2 by 3 equals 3.3 into 10 raised to 3 moles NH3. Conversion to grams is done as follows. 1 mole NH3 equals 17 grams of NH3. Hence 3.3 into 10 raised to 3 moles NH3 equals 3.3 into 10 raised to 3 into 17 grams NH3 by 1 mole NH3 equals 56.1 kilogram NH3. Example 1.6. 2 grams of substance A is added to 36 grams of water. Find the mass percentage of the solute. Solution. Total mass of the solution equals 36 plus 2 equals 38 grams. Mass percentage of the solute equals mass of solute by total mass of solution into 100 equals 2 by 38 into 100 equals 5.26%. Example 1.7. Find the molarity of NaOH in a solution when 4 grams of NaOH is dissolved in water to form 250 milliliters of the solution. Solution. We know that molarity M equals number of moles of solute by volume of solution in liters. To find the number of moles, we need to know the molecular mass of NaOH. Molecular mass of NaOH equals 1 into atomic mass of Na plus 1 into atomic mass of O plus 1 into atomic mass of H equals 1 into 23 plus 1 into 16 plus 1 into 1 equals 40 grams. Thus, number of moles of NaOH dissolved equals 4 grams by 40 grams equals 0.1 mole. Therefore, M equals 0.1 mole by 0.25 liters equals 0.4 mole per liter or 0.4 m. Thus, the molarity of NaOH in the solution is 0.4 m. Example 1.8. The density of a 0.667 m solution of glucose is 1.2 grams per milliliter. Calculate the molality of the solution. Solution. M equals 0.667 moles per liter. Mass of glucose in 1 liter of solution equals 0.667 into 180 equals 120 grams. Mass of 1 liter solution equals 1000 into 1.2 equals 1200 grams. Mass of solvent, water, equals 1200 minus 120 equals 1080 grams equals 1.08 kilograms. We know that molality of a solution is given as molality equals number of molecules of solute by mass of the solvent in kilograms equals 0.667 by 1.08 equals 0.617 m.